application. ABCD parameters, T parameters and applications. Part 1. This video is not prepared for academic purpose. It is prepared for problem solving purpose. Input voltage and current are functions of output voltage, output current. Some circuits are there. Input voltage we are giving. The outputs are connected to some load. So the input voltage and current are functions of output voltage, output current. For this, ABCD matrix is used. ABCD matrix is nothing but matrix with ABCD parameters. That is, ABCD parameters are elements of ABCD matrix. It is 2 by 2 matrix. It is very easy to do matrix multiplication, inverse matrix. ABCD parameters are used in two-port network. There are some limitations of using ABCD parameters in electrical network. ABCD parameters are valid for linear networks only. It cannot be used for non-linear network. It is used in modeling of transmission line. In this video, basic concepts are explained. Afterwards, ABCD parameters with known components and unknown components are explained. Millman theorem, source voltage, source impedance are used for solving problems. We will see basic fundamental resistor, inductor, capacitor. Resistor R ohms, inductor L henries, capacitor C farad. Values, you assume the values: resistor 5 ohms, inductor 10 henries, capacitor 4 farads. That is a ZR, that is resistor value 5 ohms, XL 10S, XC 1 by 4S. Impedance at 50 Hz. S is equal to j omega, angular frequency equal to omega is equal to 2 pi f. Now F is equal to 50 Hz. ZR is equal to 5 ohms, XL is equal to j omega 10, XC is equal to 1 by j omega 4. ZR is equal to this resistor value 5 ohms, inductor XL is equal to j 100 pi 10, XC is equal to 1 by j 100 pi 4. ZR is equal to 4 ohms, XL is equal to j 314 1.5 ohms, SC is equal to minus j 0.79 milli ohm. So finally, ZR is equal to 5 ohms, XL is equal to 3141.5 angle 90 ohms, XC is equal to 0.79 angle minus 90 milli ohms. Impedance at 0 Hz, that is DC voltage, ZR is 5 ohms, XL is equal to 0 ohms, that is equal to short circuit. XC is equal to 1 by 0 ohms, that is open circuit. Infinity resistance, so it is open circuit. Complex number R plus JX equal to Z angle theta. If V is equal to 10 angle 0 degree, Z is equal to 3 plus 4J, I equal to V by Z, that is equal to 10 angle 0 degree divided by 5 angle 53.13 is equal to 2 angle minus 53.13 degree. Another is Millman theorem. Millman theorem. Here you see 3 voltage sources are there. They are connected to the impedance Z1, Z2, Z3. Other side of the impedance are star connected and floating. The floating point is P. That is equal to V by Z1 plus V1 by Z1 plus V2 by Z2 plus V3 by Z3 whole divided by 1 by Z1 plus 1 by Z2 plus 1 by Z3. 1 by Rx is equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3. I1 is equal to V1 minus Vx by Z1. I2 is equal to V2 minus Vx by Z2. I3 is equal to V3 minus Vx divided by Z3. Applying Millman theorem, finding the source voltage, source impedance at various values. If V1 is equal to VRN equal to 230 angle 0 degree volt, V2 is equal to VYN equal to 230 angle minus 120 volt, V3 is equal to VBN equal to 230 angle 120 volt, 120 degree volt. Z1 load impedance. Z1 is equal to Z2 is equal to Z3 is equal to 200 ohms. Then Vx is equal to 0 volt. I1 equal to, that is phase current, 1.15 angle 0 degree ampere. I2 is equal to 1.15 angle minus 120. I3 equal to 1.15 angle 120. Here balanced current, magnitude and angle are balanced. Next, if V1 is equal to 230 angle 0 degree, V2 is equal to 230 angle minus 120, V3 equal to 230 angle 120, Z1 equal to 200 ohms, Z2 is equal to 200 ohms, Z3 is equal to 100 ohms. In that condition, Vx is equal to 230 angle 0 divided by 200, 230 angle 120 divided by 200 plus 230 angle 120 divided by 100 whole divided by 1 by 200 plus 1 by 200 plus 1 by 100. So Vx is equal to 57.5 120 volt. In that condition, I1 is equal to 1.32 angle minus 10 degree. I2 is equal to 1.32 minus 1.109.1. I3 is equal to 1.73 angle 120 degree. Unbalanced current, magnitude and angle are different. One by Rx equal to 1 by 200 plus 1 by 200 plus 1 by 100. So Rx is equal to 50 ohms. Now these three source voltages connected to the load impedance and floating point equal to 57.5 angle 120 is a source voltage, 50 ohms is source impedance. Now if we connect a resistance, that is load 7.5 ohms across that open terminal, that is star point, and calculate what is the current and what is the voltage, that is equal to 1 ampere. Current flowing into the resistor is 1 ampere. 1 into 7.5 ohms is equal to 7.5 volt. Here you see three resistors, 5 ohms, 10 ohms, 20 ohms are connected as a circuit. Left side of the circuit, 10 volt source is connected. Output of the circuit, that is source connected to the left side, impedance are connected, and output side VOP. VOP is equal to open circuit voltage equal to 8 volt. I short circuit current is equal to 0.571 ampere. Input current at open output is open circuit equal to 10 by 25 equal to 0.4 ampere. Input current at open output is short circuited equal to 10 divided by 5 plus 200 plus 30 equal to 0.857 ampere. Now source impedance. You are seeing from the output, source impedance equal to 10 plus 3 into 10 whole divided by 3 plus 10, that is equal to 14 ohms. For this circuit, if we apply 10 volt, source voltage equal to 8 volt, Vs equal to 8 volt. Source impedance equal to 14 ohms. ABCD parameters of circuit. Three impedance Z1, Z2, Z3 are connected as shown in figure. This is called a circuit or network. Left side of that circuit, we are applying voltage V1 and measure the voltage V2 as output voltage. See, V1 is the input voltage to the circuit that is formed by the Z1, Z2, Z3. If we connect a load or resistance impedance across the output terminal voltage is V2. The power current flow from circuit to impedance, connected load impedance is I2. From source, current flowing into the circuit is I1. Now, this input voltage and current is a functions of output voltage and current. That is, V1 is equal to AV2 plus VI2. I1 is equal to CV2 plus DI2. The same circuit is represented in figure 2 as ABCD parameters instead of network or circuit components. V1 is applied voltage, I1 is current going into the circuit. I2 is the output current from the circuit. V2 is the terminal voltage. So, V1 and I1 are function of ABCD parameter of V2 and I2. That is, input is function of output. V1 matrix V1 I1 equal to matrix ABCD into V2 I2. Output open condition I2 equal to 0. V1 is equal to AV2. I1 is equal to CV2. So, A is equal to V1 by V2. C is equal to I1 by V2. Output is short circuit condition. That is short condition. V2 is equal to 0. So, V1 is equal to BI2. I1 is equal to DI2. B is equal to V1 by I2 and D is equal to I1 by I2. All components should be linear component only. That is resistor, inductor, capacitor, transformer. That is linear network. The network should be reciprocal. Determinant of ABCD matrix equal to 1. AD minus BC equal to 1. Refer figure 1 and figure 2. In figure 1, I2 output current is coming out from circuit going to the load. In figure 2, I2 output current is coming into the circuit from output, that is load. In our video, we follow the figure 1 only, because it is easy to remember A plus B and C plus D. Figure 2 is usually used in academic purpose only. For practical purpose, figure 1 is advisable. That is, current from output current from circuit to load only. Finding ABCD parameters of a circuit with known components. Method 1. Here Z1, Z2, Z3, three components are in the circuit as shown in figure. For that, a matrix ABCD is shown here. Suppose Z1 is equal to 5 ohms, Z2 is equal to 10 ohms, Z3 is equal to 20 ohms. ABCD matrix is 1.25, 17.51, 0.05, 1.5. That is, A is equal to 1.25, B is equal to 17.51, C is equal to 0.05, D is equal to 1.5. each component is having its own ABCD matrix. Z1, it is connected seriously. ABCD matrix of Z1 is 1, Z1, 0, 1. Z3 component is parallelly connected. ABCD matrix of Z3 is 1, 0, 1 bar Z3, 1. Z2 is connected seriously. ABCD matrix of Z2 is 1, Z2, 0, 1. These components Z1, Z3, Z2 are connected as cascaded connections. So the matrix of Z1, Z3, Z2 are multiplied. So total circuit ABCD matrix is a multiplication of these three components matrix. So finally you will get this value. Method 3. In this method, we will calculate open circuit voltage, short circuit current and input current for an applied voltage. Assume here 10 volt is connected to the, here 10 volt is applied in our circuit, 5 ohms, 10 ohms, 20 ohms components. We open, the open circuit voltage is equal to 8 volt. I short circuit, that is short circuit is equal to 0.571 ampere. Input current at output open condition is equal to 10 by 25 equal to 0.4 ampere. Input current at output short circuit equal to 10 bar 5 plus 200 by 30 is equal to 0.857 ampere. So A is equal to V1 by V2 and C is equal to I1 by V2 and open circuited conditions. A is equal to 10 bar 8, that is equal to 1.25, and C is equal to 0.4 bar 8, that is equal to 0.05. Now short circuited conditions. B is equal to V1 by I2 and D is equal to I1 by I2. B is equal to 10 bar 0.571, that is equal to 17.51. D is equal to 0.857 bar 0.571 equal to 1.5. So AD minus BC is equal to 1. So totally the ABCD matrix of this circuit is 1.25, 17.51, 0.05, 1.5. Finding ABCD parameters of a circuit with the unknown components. Output short circuit is not advisable because it may be very high current. Apply AC voltage at input terminal. Measure input current, output voltage. Connect a load resistance at output. Apply AC voltage at input terminal. Measure input current and output voltage. Output current is equal to output voltage divided by resistance. Find ABCD parameters. Find AC of ABCD parameters. A is equal to V1 by V2. C is equal to I1 by V2 when output terminals are open. Find B when output terminals are connected to RL using equation. V1 is equal to AV2 plus BI2. Find D when output terminals are connected to RL using equation. I1 is equal to CV2 plus DI2. Apply 10 volt at input terminals. V1 is equal to 10 volt. Measured output voltage and input current. V2 is equal to 8 volt. I1 is equal to 0.4 ampere. A is equal to V1 by V2 equal to 10 bar 8 equal to 1.25. C is equal to I1 by V2. equal to 0.4 divided by 8 equal to 0.05. Connect a load resistance 10 ohms at output terminals. Apply 10 volt at input terminal. Measured output voltage and input current. V2 is equal to 3.33 volt. I1 is equal to 0.666 ampere. Output current, output voltage divided by resistance. 3.33 divided by 10 equal to 0.33 ampere. V1 is equal to AV2 plus BI2. 10 is equal to 1.25 into 3.33 plus B into 0.33. B is equal to 10 minus 1.25 into 3.333 whole divided by 0.33 equal to 17.51. I1 is equal to CV2 plus DI2. 0.666 equal to 0.05 into 0.33 plus D into 0.333. D is equal to 0.666 minus 0.05 into 3.33 whole divided by 0.33 equal to 1.5. So A is equal to 1.25, B is equal to 17.51, C is equal to 0.05, D is equal to 1.5. ABCD parameters and source voltage, source impedance. Here we are going to see source voltage, source impedance from ABCD parameters with sub applied voltage. Source voltage is equal to V2 for V1 with output open circuit, that is equal to V1 bar A. Short circuit current is equal to I2 for same V1 with the output short circuit, V1 bar B. Source impedance equal to source voltage by short circuit current, V1 bar A divided by V1 bar B, that is equal to V by A. Suddenly it is very difficult to remember that one. So here one example we are given. 10 volt is applied a network or a circuit with the ABCD parameter 1.25, 17.5, 0.05, 1.5. Source voltage is equal to Vs equal to V1 by E, that is 10 bar 1.25 equal to 8 volt. Short circuit current is equal to V1 bar B, that is equal to 10 bar 17.5, that is equal to 0.571. So source impedance equal to source voltage by source current, short circuit current, that is equal to 8 bar 0.571, that is equal to 14 ohms. Finding terminal voltage of a circuit with a load for an input voltage. Case 1. If input voltage V1 is equal to 10 volt, what is the voltage across the loading resistor RL equal to 10 ohms for the circuit, which is having the ABCD parameters 1.25, 17.5, 0.05, 1.5. Source voltage is equal to Vs equal to V1 bar A, that is equal to 10 bar 1.25 equal to 8 volt. Short circuit current is equal to V1 bar B, that is equal to 10 bar 17.5 equal to 0.571. Source impedance equal to source voltage divided by short circuit current, that is equal to 8 bar 0.571 equal to 14 ohms. Voltage across 10 ohm loading resistor, that is equal to 10 into 8 bar 14 plus 10, that is equal to 3.33 volt. Current equal to 3.33 divided by 10 is equal to 0.333 ampere. Loading resistor 10 ohm is connected across the output terminal of a circuit which is having a ABCD parameter of 1.25, 17.5, 0.05, 1.5. Since 10 ohm is parallelly connected to the circuit, the ABCD parameter of 10 ohm is 1, 0, 1 bar 10, 1. Multiplication of these two matrices, you will get a total ABCD parameter. that is 3, 17.5, 0.2, 1.5. If we apply 10 volt as input to this circuit with the loading resistor, total ABCD parameter is 3, 17.5, 0.2, 1.5. The output voltage is 10 bar 3. Voltage across the loading resistor is equal to 10 bar 3 is equal to 3.33 volt. Current is equal to 3.33 divided by 10 equal to 0.33 ampere. Finding terminal voltage of a circuit with a load at different voltage. Case 2. If input voltage V1 is equal to 40 volt, what is the voltage across loading resistor RL equal to 10 ohms for the same circuit? Here, the input voltage is increased from 10 volt to 40 volt. The circuit the circuit ABC parameters are 1.25, 17.5, 0.05, 1.5. RL resistor 10 ohm is connected across the output terminal. Source voltage equal to Vs equal to V1 by A, that is equal to 40 bar 1.25 equal to 32 volt. Short circuit current is equal to V1 by B, that is equal to 40 divided by 17.5 equal to 2.286. Source impedance equal to source voltage divided by short circuit current, that is equal to 32 bar 2.286 equal to 14 ohms. Voltage across 10 ohm, that is loading resistor, is equal to 10 into 32 divided by 14 plus 10 equal to 13.33 volt. Current is equal to 13.33 divided by 10 equal to 1.33 ampere. Finding terminal voltage of two circuits parallel without a load and with different input voltages. That is, one voltage is 40 volt, another is 10 volt. Two circuits with the same parameters. That is, ABCD parameters 1.25, 17.5, 0.05, 1.5. Two circuits are parallelly connected. Outputs are parallelly connected. Input is one side is 40 volt, another circuit 10 volt. Two sources with the same ABCD parameters. First source is 40 volt with the same circuit is equal to source voltage is 32 volt and source impedance is 14 ohms. Second circuit 10 volt side. 10 volt with the same circuit is equal to source voltage is 8 volt and source impedance is 14 ohms. Now VAB is parallelly connected, parallel point of these circuits. Vs, as per Millman theorem, Vs equal to 32 bar 14 plus 8 bar 14 whole divided by 1 bar 14 plus 1 bar 14 is equal to 20 volt. Left side is 40 volt side, right side is 10 volt side. Output of both the circuits are parallel. Output voltage of the output terminal is 20 volt. That is VAB equal to 20 volt. VAB is equal to 20 volt. So current from left side equal to 32 minus 12 whole divided by 14 equal to 0.857 ampere. Current from right side equal to 8 minus 12 whole divided by 14 equal to minus 8.7 ampere. That is current is reversed. So from circuit 1, current output to output terminal is 0.857 ampere. For circuit 2, current going into the circuit from output terminal is 0.857 ampere. 40 volt side, output current is 0.857 ampere. Output terminal voltage is 20 volt. So I1 is equal to 0.05 into 20 plus 1.5 into 0.857 is equal to 2.29 ampere. That is, current from 40 volt is 2.29 ampere. 10 volt side 0.857 ampere is going into the circuit from output terminal. Output terminal voltage is 20 volt. So I1 is equal to 0.05 into 20 plus 1.5 into minus 0.857 equal to minus 0.29 ampere. So current at 10 volt source, current from 10 volt source equal to minus 0.29 ampere. Finding terminal voltage of two circuits parallel with a load and with different input voltages. Output of two circuits with the same ABCD parameter with different input voltages 40 volt, 10 volt are parallel and connected to a load resistance 3 ohms. Find the source voltage and source impedance at terminal AB without load impedance 3 ohms. VAB equal to VS equal to 32 bar 14 plus 8 bar 14 whole divided by 1 bar 14 plus 1 bar 14 equal to 20 volt. 1 by ZS equal to 1 bar 14 plus 1 bar 14. So ZS equal to 7 ohms. Now source voltage 20 volt and 7 ohms, source impedance 7 ohms is appearing at terminal AB. Now connect loading resistor 3 ohms across terminal AB. Current in 3 ohms equal to 20 divided by 7 plus 3 equal to 2 ampere. Voltage across 3 ohms equal to 3 into 2 equal to 6 volt. Now VAB voltage, that is across the loading resistor 3 ohms, voltage is equal to 6 volt. VAB equal to 6 volt. So current from left side equal to 32 minus 6 whole divided by 14 equal to 1.857 ampere. Current from right side equal to 8 minus 6 divided by 14 equal to 0.143 ampere. Now we are going to see the current output from 40 volt and 10 volt source. Output current from circuit connected with the 40 volt is equal to 1.857 ampere and the terminal voltage is 6 volt. So I1 is equal to 0.05 into 6 plus 1.5 into 1.857 equal to 3.09 ampere. Current from circuit connected with 10 volt is equal to 0.143 ampere with terminal voltage 6 volt. I1 is equal to 0.05 into 6 plus 1.5 into 0.143 equal to 0.52 ampere. So from 40 volt source 3.09 ampere is coming. From 10 volt source 0.52 ampere is coming. Long cascaded T network. 6 sets of circuits equal voltages are connected as shown in the figure. ABCD parameter matrix of one circuit equal to matrix ABCD. ABCD parameter matrix of total circuit as shown in the figure equal to matrix ABCD power 6. If matrix ABCD of one circuit equal to 1.25, 17.51, 0.05, 1.5, then matrix power 6 equal to 67.4688, 1442.3374, 4.1186, 88.0618. That is, ABCD parameter of the total circuit is 67.468, 1442.3374, 4.1186, 88.0618. Thank you very much for watching this video. We hope you have more knowledge about ABCD parameter after watching this video. If you need any clarification, you can write to us. Our email ID is anbu.electric.y@gmail.com.